Right, so unit 7.H1. This is the law of sines. This is the first honors section in unit 7. And we, at the end of this section, you should be able to solve problems using the law of sines. But before you can solve problems using the law of sines, you need to understand what the law of sines is and what it says. So it turns out in the real world, there are triangles other than right triangles. Here's an example of one. And in the past, we have, identified line segments of triangles by the vertices bounding those line segments. Like this is this line segment would be line segment AB. This line segment would be line segment BC, and this line segment would be line segment AC. But when we're talking about the line segments for law of sines, we're gonna we are going to identify the line segments by the angle opposite of that line segment, right? So this line segment we're gonna identify as little. This is big C. You can't really differentiate between big C and little c too easily, but this would be lowercase c, line segment lowercase c. If I could write in italics, I would. That's lowercase c, right? So if this is capital A, this line segment would be lowercase a, italics. And if this would be big B, this would be lowercase b. Okay, this would be line segment lowercase b. All right, so that's how we're going to identify these line segments, and that's going to help define the the law of sines a little easier. Okay, so although we cannot, say that this is a right angle inside these triangles, most triangles you can take at least one of these angles and split it in two, whether it's bisect it or make it evenly in two or unevenly in two. It doesn't matter, but you can take one of those angles. Where I'm going to take angle B, and I'm going to cut it in two and make it intersect one of the line segments at a 90-degree angle. So in this case, it's going to intersect line segment B at a right angle. Therefore, making two, that's a really bad right angle. Making angle, that's better. Therefore, making two 90-degree two right angles. Okay, so now I can define things in terms of, we're going to define things in terms of sine here, because we're going to say we're going to define, because this is the law of sines, right? So we're going to say here now that the sine of A, let's label this K, by the way. Let's make that K. Okay, so the K is the opposite of both A and C, right? So the sine of A is opposite, which is K. Let's color code a little bit better here. Is K over C. That's little c, lowercase c, right? And the sine of C, the sine of big C, the angle C, equals opposite, our line segment K that we made divided by our lowercase a. All right. So now we look at here what component of these equations, what term of these equations is common in both equations. And we would say, well, it's pretty obvious. Little c and big C, those are two different things. Little a and big A, those are two different things. Sine of C and sine of A, those are two different things, right? But K is common. So let's solve everything in terms of K, and then and see what we can do from there. Okay. So in order to solve everything for K, let's multiply both sides with equations. Let's move the K over here. Well, actually, let's isolate K. So let's multiply C, little c times the sine of A by both sides, and that would equal K. And then multiply A by both sides by the sine of C for this equation equals K. Right, so by the transitive property or substitution property, we can say, right, if this and this equal each other, right, then we can say that this and this equal each other. These both equal K. Right, so if this equals K, if this equals K, and this equals K, I can say, let me just put some equal signs here, right? That is true, right? So I can just erase this one. Still true. Still true. Okay, so now I have myself an interesting relationship here. C sine of A equals A sine of C. Pretty interesting, but let's put this in a little bit more useful terms. Okay, let's go ahead and put this in a ratio form, right? A ratio in a way that we can be a little bit more useful, right? So if I were to put this in a ratio term, I would move the C on this side over to here, and move the A to this side over to here, right? So it would be the sine of A divided by the length of A equals the sine of, this would be a big C. It doesn't look like a big C. Sine of C, sine of C divided by the length of C. Okay, so that is effectively an example of the line of the law of sines in action. Right? You could also put in here the sine of B over B, and that would complete the circuit here, right? Because if you were to like use this one, this as the as K, the relationship would hold true, right? But you could also use the inverse. The inverse of this would also be true. So you could say A equals C, equals, I'm just going to rewrite this so it makes more sense, equals B equals C over over sine of A, sine of B, sine of C. I just did it A, B, C instead of A, C, B, right? The inverse is also true. So this, my friends, is the law of sines. Okay? So let's put that to practice here and do an example. Okay? Let's do... Let me get one ready. I'll pause it. I'll get one ready. Okay, so here's our example. We have this triangle LKS, L equals 6, LS equals 6, measure of angle KLS equals 31, measure of angle KSL equals 107, and then we have to determine KS. All right, well that's kind of ambiguous without a drawing, so let's make a little drawing here to show that. So it's going to kind of look something like this, not to scale. It's going to look something like this. Like I said, not to scale, but kind of close. Okay. So this is going to be LKS, right? And this is going to be, let's see, so this is measure M. So remember, when you're reading these, and there's only one vertice for each, you really only have to look at the middle letter. So this is L. This is 31 degrees. This is this S is 107. And then LS, remember, so this is LS, so this is actually, we're going to do this, this is K, so this is K, because it doesn't have K in it, so you know it's the one opposite of K, right? Does that make sense? Because this is bound by L and S, so because it's bound by these two angles, it must be the opposite of K, because it's bound by L and S. And if it doesn't touch L or S, it must be opposite of K, right? So visually that should make sense. So we have to find KS, the length of KS, so that we must find L. So we got to find L. Okay, so knowing these things here, right, we can figure out what do we have. Well, we know we got to figure out, we have the sine and the sine, right? So we got to figure out the sine of L, and well, the sine of K. All right, so so let's figure out these things. All right, so we have the sine of, we need to find the sine of L equals the sine of K. All right, and then we got to use these two proportions. So we know L, well, we don't know L, but we know K, right? All right, so we can figure these. Oh wait, can we figure that out? We weren't given that. Well, we kind of were though. Like we were given this, we were given that. We know that the interior angles of a triangle equals 180. So we know we can figure that out real easy, right? So 31 plus 107 equals 180 minus 180, right? So it's 42. So we know that this is 42. Okay, so don't let that throw you off. Don't forget the simple stuff, right? So all I got to do is rearrange this equation, and then we'll plop the numbers in, plug and chug, and we'll figure that out. All right, so figure this out. You can cross multiply. If you don't know, if this isn't super intuitive to you, I'll show you how to do the algebra real quick. You can cross multiply to get it all on one line and get rid of the fractions. So this will be the sine of L times K equals the sine of K times L. And then we're solving for L. So L is going to be equal to, I'll make that bigger. So L is going to be equal to the sine of L divided by, or times K, sine of L, don't forget that K, I almost did, times K divided by the sine of K. The sine of K. Alright, so we'll do L equals, alright, so the sine of L, so we're going to do L, which is the sine of 31 times 7 divided by, and then the sine of 42, that's a 7, the sine of 42, so we'll do that, right? So 7 times 31 equals, divided by 42 sine equals, so L equals 5.39. Does that pass the dummy check? So we're saying this equals 5.39. Well, that is the smallest, it's opposite the smallest angle in the group. This is 7. This is the smallest angle of the 3. It makes sense that that is the smallest length and is smaller than 7, but by not like tremendously, by a tremendous amount. Right, so there you go. Just that's how you do it. You can just kind of substitute A, B, and C with L and K. Just recognize that the opposite letters are replace the A's and the B's, right? And the C's. You can use the sine of L's, the sine of K's, and you're home free. Hopefully that makes sense for you. If you have any questions, just let me know.